Question 1. In the context of a commercial office building in a humid climate, Mr. Alvarez is designing a ventilation system to ensure indoor air quality while minimizing energy use. He must decide between a standard exhaust system and an energy recovery ventilator of considering latent heat loads and moisture control. What should Mr. Alvarez prioritize in his design? A. Selecting an earth to recover moisture and sensible heat from exhaust air. B. Using a standard exhaust system to avoid complexity and reduce maintenance. C. Designing for maximum outdoor air intake without heat recovery. D. Installing a heat recovery wheel that only transfers sensible heat. Answer. Correct answer. D. Explanation. An energy recovery wheel that transfers only sensible heat is ideal in humid climates to prevent bringing in moisture from exhaust air, avoiding increased latent loads inside the building. Hoods that transfer moisture, latent heat, can inadvertently introduce humidity, increasing cooling load and occupant discomfort. Simply maximizing outdoor air intake without heat recovery results in high energy consumption. A standard exhaust system without heat recovery misses energy-saving opportunities. Sensible only heat recovery balances energy efficiency with moisture control, crucial in humid climates to prevent condensation and mold issues. Question 2. From the perspective of fluid dynamics, Patel is analyzing duct system pressure drops in a new HVAC design. The ducts have several sharp bends and sudden expansions. Which principle best explains how these features affect system performance? A. Sharp bends and sudden expansions increase turbulence and cause higher pressure drops. B. Sharp bends improve airflow by accelerating velocity and reducing resistance. C. Sudden expansions decrease pressure losses by allowing air to slow down gradually. D. Duct surface roughness has a greater impact than bends or expansions on pressure drop. Answer. Correct answer. A. Explanation. Sharp bends and sudden expansions create turbulence, disrupting smooth airflow, which increases frictional losses and pressure drops. This demands more fan power, reducing system efficiency, while surface roughness does influence pressure drop. Geometric changes like bends cause flow separation and eddies, which are more significant contributors. Sudden expansions typically cause abrupt velocity changes, increasing losses and decreasing them. Proper duct design avoids sharp bends or uses gradual transitions to maintain laminar flow and minimize energy consumption. Question 3. Given the circumstances of a high-rise office tower experiencing uneven heating and cooling, Istakim is considering zoning strategies to enhance occupant comfort. What is the best approach for zoning in this scenario? A. Zoning based solely on architectural flaws for simplicity. B. Dividing zones by exposure and occupancy to match heat gains and usage patterns. C. Creating one large zone per HVAC unit to reduce control complexity. D. Zoning by room size regardless of usage or heat gain. Answer. Correct answer. C. Explanation. Creating one large zone per HVAC unit may simplify controls but often causes discomfort due to uneven heating and cooling, especially in tall buildings with variable loads by orientation and usage. Effective zoning requires consideration of exposure, solar gain differences, and occupancy patterns to optimize energy use and comfort. Zoning by floor alone may not account for internal heat gains or use variance. Zoning by room size without considering function or heat load ignores critical factors affecting thermal comfort. The goal is precise control where loads vary significantly. Question 4. Considering the evidence on refrigerant environmental impact, Rodriguez is tasked with selecting a refrigerant for a new chiller system. What principle should guide her choice? A. Selecting a refrigerant with the lowest ozone depletion potential (OP) and global warming potential. B. Prioritizing refrigerant cost above all environmental factors. C. Choosing the refrigerant with the highest cooling capacity regardless of environmental effects. D. Using only refrigerants phased out by current regulations to maximize efficiency. Answer. Correct answer. B. Explanation. Environmental impact, especially load PWA, a primary factor in refrigerant selection to comply with regulations and sustainability goals. Prioritizing cost without regard to environmental effects risks non-compliance and future retrofits. Selecting refrigerants with high cooling capacity but high environmental impact violates industry trends and legal mandates. Using phased-out refrigerant Illegal and environmentally harmful. The best practice balances performance, cost, and minimal environmental footprint, following standards such as ASHRAE 34 and international protocols. Question 5. While examining psychrometric data for a manufacturing facility, ISTASYNC notices that the design dry bulb temperature is 95 degf and the wet bulb is 75 degf. What does this difference primarily indicate regarding latent and sensible heat loads? A large difference shows significant latent heat load due to moisture in the air. B. Small difference means latent heat load is negligible and only sensible heat matters. C. Wet bulb temperature determines sensible heat exclusively. D. Dry bulb temperature directly indicates latent heat load. Answer. Correct answer. C. Explanation. The wet bulb temperature relates to both sensible and latent heat, but the dry bulb temperature primarily measures sensible heat. A large difference between dry and wet bulb implies significant moisture, latent heat load. Wet bulb temperature helps calculate total heat content and latent load. It does not measure sensible heat exclusively. Dry bulb temperature alone does not indicate latent heat, but helps to sensible heat. Understanding the relationship among these temperatures is essential for accurate HVAC load calculations. Question 6. In a modern context of HVAC control systems is new and is deciding between pneumatic and digital controls for a new hospital project. Considering accuracy, maintainability, and integration, what is the best recommendation? A. Pneumatic controls for reliability and ease of repair. B. Digital controls for precise operation and integration with building automation. C. Pneumatic controls to reduce upfront costs despite limited scalability. D. Digital controls only for new buildings, pneumatic for retrofits. Answer. Correct answer. D. Explanation. Digital controls offer superior precision integration with building automation systems and remote monitoring, essential in complex environments like hospitals. However, pneumatic controls remain prevalent in many retrofits due to lower initial costs and existing infrastructure compatibility. New hospital projects benefit most from digital systems for better energy management and fault detection. New controls have limitations in scalability and fine control, making them less suited for modern applications, though still useful in specific retrofit scenarios. Question 7. When analyzing heat load calculations for a warehouse with large door openings, Mr. Thompson is confused about accounting for infiltration losses. What is the proper way to include infiltration in heat load calculations? A. Ignore infiltration because door openings are infrequent. B. Estimate infiltration rates based on door usage frequency and outdoor conditions. C. Use fixed infiltration values from building codes regardless of actual conditions. D. Treat infiltration as part of ventilation load only. Answer. Correct answer. B. Explanation. Infiltration must be estimated realistically based on actual door opening frequency, weather conditions, and building tightness, as it contributes both sensible and latent heat loads. Ignoring infiltration underestimates load, risking undersized HVAC systems. Fixed code values may be conservative but lack accuracy for specialized buildings. Infiltration differs from mechanical ventilation as it is uncontrolled air leakage. Correctly estimating infiltration is critical to ensure proper system sizing and occupant comfort. Question 8. Through careful analysis of ductwork design, Lopez identifies excessive static pressure in the system. Which strategy should she implement to reduce static pressure without compromising airflow? A. Increasing duct size and minimizing sharp bends or restrictions. B. Installing more powerful fans without changing duct design. C. Adding flexible ducts to bypass restrictive sections. D. Using smaller ducts to increase air velocity and reduce pressure drop. Answer. Correct answer. C. Explanation. While increasing duct size and minimizing restrictions is the best practice for reducing static pressure, adding flexible ducts typically introduces more restrictions and turbulence, worsening pressure drop. Using more powerful fans without addressing duct design only increases energy consumption and noise. Smaller ducts increase velocity but also friction losses and pressure drop. The correct approach optimizes duct sizing, layout to maintain efficient airflow and reduce static pressure. Question 9. Given the circumstances of designing HVAC for A data center instagacia is deciding on the cooling strategy. What factor is most critical to ensure effective temperature control and equipment longevity? A. High airflow rates to dilute heat loads evenly. B. Maintaining tight temperature and humidity control with redundancy. C. Using natural ventilation to reduce energy costs. D. Installing oversized equipment to handle peak loads easily. Answer. Correct answer. A. Explanation. Data centers require tight temperature and humidity control, often with redundancy and precise cooling to prevent equipment failure. High airflow rates help distribute cooling but must be carefully balanced with humidity control. Natural ventilation is generally inadequate due to dust and humidity concerns. Oversized equipment wastes energy and can cause short cycling, reducing lifespan. Designing for redundancy and precise control is essential to maintain reliability and efficiency in data centers. Question 10. Within the framework of energy recovery systems, Evans must decide between enthalpy wheels and heat pipes for a hospital project. Which factor best determines their selection? A. Sensible and latent heat recovery efficiency under variable humidity conditions. B. Initial cost differences favoring heat pipes universally. C. Simplicity of installation favoring enthalpy wheels. D. Maintenance requirements favoring heat pipes despite lower efficiency. Answer. Correct answer. B. Explanation. While enthalpy wheels provide simultaneous sensible and latent heat recovery with high efficiency, heat pipes typically have lower initial costs and simpler maintenance. For hospitals with variable humidity, enthalpy wheels perform better but at higher costs. Installation complexity may be higher for enthalpy wheels but offers greater energy savings. Maintenance considerations vary by system and application. Choosing between these depends on project budget, humidity control needs, and long-term energy savings. Question 11. Given the circumstances of a multi-zone commercial building, Carter is designing the HVAC zoning system. She notices that certain zones have frequent occupancy changes and varying heat gains throughout the day. What is the best zoning strategy to optimize energy use and occupant comfort? A. Use large zones grouped by floors for simpler control. B. Design small occupancy-based zones with independent temperature control. C. Zone based solely on HVAC equipment capacity without regard to occupancy. D. Combine high occupancy areas into a single zone and isolate others. Answer. Correct answer. B. Explanation. Designing small occupancy-based zones allows the HVAC system to respond precisely to varied thermal loads and occupancy schedules, reducing wasted energy and enhancing comfort. Large floor-based zones ignore internal variations and can cause overconditioning or discomfort. Zoning solely by equipment capacity neglects occupant comfort and fluctuating loads. Grouping high occupancy areas in one zone may partially but fails to address dynamic changes across all zones. Tailored zoning maximizes system efficiency and occupant satisfaction. Question 12. From the perspective of psychrometrics, Lee is evaluating ventilation air conditions for a pharmaceutical clean room. The design requires tight control over temperature and humidity. Which parameter should he prioritize to maintain product integrity? A. Dry bulb temperature to control sensible heat. B. Dew point temperature to manage latent moisture levels. C. Wet bulb temperature to balance both sensible and latent heat. D. Relative humidity as a direct measure of moisture content. Answer. Correct answer. D. Explanation. Relative humidity directly expresses the moisture level relative to temperature, critical in clean rooms where excess moisture can affect product quality, while dry bulb temperature relates to sensible heat, and dew point defines moisture saturation. Relative humidity allows active control over moisture levels to avoid contamination and maintain sterile conditions. Wet bulb temperature reflects combined heat effects. Less intuitive for direct moisture control. Accurate RH control is essential for pharmaceutical environments. Question 13. Considering the evidence on system efficiency, Gomez must select between constant volume CV and variable air volume VEV HVAC systems for a new office building. Which factor best supports choosing a VAV system? A. Simpler control and lower initial cost. B. Better energy efficiency by modulating airflow to match load. C. Uniform temperature delivery regardless of zone load. D. Reduced maintenance complexity compared to CV systems. Answer. Correct answer. C. Explanation. While VAV systems modulate airflow to save energy and improve comfort, they can struggle with maintaining uniform temperature across all zones under varying loads. CV systems deliver constant airflow, providing steady temperature but wasting energy when loads are low. VAV systems require more sophisticated controls and maintenance, but offer significant energy savings. Therefore, uniform temperature delivery generally better achieved with CV, making this a critical consideration depending on project priorities. Question 14. Under the assumption that a chilled water piping system is experiencing excessive pressure loss, what is the most effective design adjustment to reduce this loss without increasing pump size? A. Increasing pipe diameter to reduce friction. B. Adding more elbows to distribute pressure evenly. C. Using smaller pipes with higher flow velocity. D. Installing throttling valves to control pressure drop. Answer. Correct answer. A. Explanation. Increasing pipe diameter reduces water velocity, which lowers friction or pressure loss, enhancing system efficiency without needing a larger pump. Adding elbows increases turbulence and pressure drop, worsening the problem. Smaller pipes raise velocity and friction loss, increasing pump work. Throttling valves create additional pressure drop deliberately and do not reduce overall losses. Proper pipe sizing based on flow and friction principles is essential for optimal chilled water system design. Question 15. Taking into account the interrelationship between duct material and system performance, which material choice would be best for a hospital HVAC system requiring minimal contamination risk and ease of cleaning? A. Galvanized steel ducts with smooth interior finish. B. Flexible ductwork for easier installation in tight spaces. C. Fiberglass duct lining for noise attenuation. D. Aluminum ducts for lightweight and corrosion resistance. Answer. Correct answer. C. Explanation. Fiberglass duct lining improves noise control and can be sealed for contamination prevention, but it can harbor dust if not properly maintained, making it less ideal for hospitals. Galvanized steel ducts with smooth interiors resist contamination buildup and are easier to clean, preferred in healthcare environments. Flexible ducts, although convenient, are prone to air leakage and microbial growth, unsuitable. Hospitals. Aluminum is lightweight and corrosion resistant, but less durable and costlier than steel for large systems. Material choice balances hygiene and maintenance. Question 16. As illustrated by recent developments, Chen is choosing an HVAC control strategy for a high-rise building with mixed-use spaces. What control approach best accommodates variable occupant densities and load profiles? A. Single thermostat control per floor for simplicity. B. Zone control with demand-based modulation and occupancy sensors. C. Manual override controls only, avoiding complex automation. D. Fixed setpoint controls based on average built-in load. Answer. Correct answer. B. Explanation. Zone control with demand-based modulation and occupancy sensors allows the system to adapt dynamically to actual occupant presence and load variation, optimizing comfort and energy efficiency. Single thermostat per floor ignores internal variations, leading to discomfort and energy waste. Manual override only lacks responsiveness and fails to capitalize on automation benefits. Fixed set points respond to real-time conditions, often resulting in inefficient operation. Smart control strategies are vital for modern mixed-use buildings. Question 17. When analyzing the merits of different heat recovery technologies, Sanders must choose between a plate heat exchanger and a rotary heat wheel for a data center with strict humidity control requirements. What key factor influences her decision? A. Plate heat exchangers provide better latent heat recovery under variable humidity. B. Rotary heat wheels are more compact and less maintenance intensive. C. Plate heat exchangers avoid cross-contamination by keeping air streams separate. D. Rotary wheels have higher initial costs but longer lifespan. Answer. Correct answer. A. Explanation. Plate heat exchangers excel at latent heat recovery, critical for humidity control in sensitive environments like data centers. Rotary wheels can transfer both sensible and latent heat, but risk cross-contamination unless equipped with seals, which can be maintenance heavy. Plate exchangers keep air stream separate, reducing contamination risk. Rotary wheels are typically more compact but may require maintenance. Choosing the right technology balances efficiency, contamination control, and operational complexity. Question 18. For the purpose of load calculation, Mr. Johnson is considering infiltration and ventilation separately in a residential building. Why is it important to distinguish between these two when sizing HVAC equipment? A. Both contribute equally to sensible heat load and can be combined. B. Ventilation is controlled air exchange, while infiltration is uncontrolled leakage, affecting load differently. C. Infiltration has no impact on latent heat loads, only ventilation does. D. Both are negligible and generally ignored in modern load calculations. Answer. Correct answer, D. Explanation. Ventilation is mechanical, controllable, fresh air supply required for indoor air quality, whereas infiltration is unintended air leakage. Both affect sensible and latent loads differently. Ventilation usually more consistent, infiltration variable and less predictable. Ignoring either can cause improper equipment sizing. Both contribute significantly to total heat loads and must be accounted for separately to accurate system design and occupant comfort. Modern load calculations incorporate both carefully. Question 19. Throughout the course of commissioning, a new HVAC system, Malik discovers that several zones are failing to reach set point temperatures during peak load. What is the most likely cause related to duct design? A. Undersized ductwork causing excessive pressure drop and insufficient airflow. B. Oversized ducts causing noise and poor temperature control. C. Use of rigid ducts rather than flexible ducts. D. Lack of duct insulation increasing heat losses. Answer. Correct answer, A. Explanation. Undersized ducts cause high friction and pressure drop, limiting airflow delivery to zones and preventing temperature control at peak loads. Oversized ducts reduce velocity, causing noise and stratification, but generally don't limit airflow. Duct material choice affects installation but not airflow capacity directly. Lack of insulation leads to energy losses but rarely causes failure to reach set points alone. Proper duct sizing and layout ensure adequate airflow and temperature control under design conditions. Question 20. To what degree does incorporating building automation systems, BAS, impact HVAC system operational efficiency in large commercial buildings? A. BAS has minimal impact beyond basic scheduling. B. BAS enables real-time monitoring and adaptive control, significantly improving efficiency. C. BAS only increases complexity and cost without measurable benefits. D. BAS replaces mechanical systems entirely. Answer. Correct answer, C. Explanation. Building automation systems BAS allow sophisticated real-time control, fault detection, and adaptive scheduling, which can significantly improve HVAC efficiency and occupant comfort in large buildings. While BAS adds complexity and initial costs, benefits often outweigh drawbacks through energy savings and reduced maintenance. BAS does not replace mechanical systems but enhances their control. Claiming minimal impact. Complexity without benefits overlooks proven industry outcomes. Efficient BAS integration is key to modern HVAC performance. Question 21. When faced with designing a chilled water system for a large commercial building, Mr. Davis notices that the return water temperature is consistently higher than expected. Which design factor is most likely contributing to this issue? A. Oversized chillers causing insufficient cooling load cycling. B. Insufficient flow rate in the chilled water circuit reducing heat transfer. C. Excessive pipe insulation increasing return water temperature. D. Using variable speed pumps to maintain constant flow. Answer. Correct answer, B. Explanation. Insufficient flow rate in the chilled water circuit limits the amount of heat absorbed, causing the return water temperature to rise. Oversized chillers generally cause short cycling but do not directly raise return water temp. Excessive pipe insulation reduces heat loss, which would lower, not raise, return temperature. Variable speed pumps adjust flow dynamically to maintain system efficiency but don't inherently cause high return temperatures. Proper flow rates ensure effective heat transfer and maintain design temperature differentials. Question 22. Across different scenarios, Morales is selecting duct materials for a coastal facility exposed to salt air. Which duct material offers the best resistance to corrosion while maintaining structural integrity? A. Galvanized steel with zinc coating. B. Aluminum, due to natural oxide film formation. C. Stainless steel, due to inherent corrosion resistance. D. Fiberglass duct board for corrosion resistance. Answer. Correct answer, C. Explanation. Stainless steel provides superior corrosion resistance in harsh saltaire environments due to its chromium oxide protective layer, maintaining strength and durability. Galvanized steel offers some corrosion protection but can degrade quickly in coastal environments. Aluminum resists corrosion via oxide formation but is soft and can be damaged easily. Fiberglass duct board is resistant to corrosion but structurally robust, unsuitable for high-pressure applications. Choosing stainless steel ensures longevity and reliability. Question 23. Given the importance of energy recovery systems in green buildings, Nguyen is evaluating rotary heat wheels versus plate heat exchangers. Which aspect is most critical when selecting between the two for variable load conditions? A. The ability of rotary wheels to handle higher airflow rates effectively. B. Plate exchangers lower initial cost and simplicity. C. Rotary wheels' tendency to transfer both sensible and latent heat with potential cross-contamination. D. Plate heat exchangers requirement for frequent maintenance. Answer. Correct answer, A. Explanation. Rotary heat wheels excel in handling large airflow volumes and adapt better to variable load conditions, making them suitable for buildings with fluctuating ventilation demands. While they transfer both sensible and latent heat, they may pose cross-contamination risks without proper sealing. Plate exchangers have simpler construction and lower initial cost, but generally handle lower airflow rates and are less efficient. Variable loads. Maintenance needs vary but do not outweigh capacity and load adaptability factors. Question 24. Taking into account the fundamental principles of psychrometrics, Mr. Singh is analyzing humidification methods for a hospital. Which humidification approach provides the most precise control of humidity without increasing latent loads excessively? A. Steam injection humidification. B. Ultrasonic humidifiers with no heat addition. C. Evaporative humidifiers using warm water. D. Direct air atomization with cold water spray. Answer. Correct answer, A. Explanation. Steam injection humidification offers precise control over humidity levels without adding significant latent loads or cooling effects essential in sensitive hospital environments. Ultrasonic humidifiers are efficient but risk uneven distribution and particulate generation. Evaporative humidifiers can add heat and moisture inconsistently. Direct air atomization adds moisture but may cause cooling and increased latent load. Steam injection is controllable and clean, meeting strict healthcare requirements. Question 25. For the purpose of reducing duct leakage in a large commercial HVAC system, Brown is reviewing sealing methods. Which sealing approach is considered most durable and effective for long-term airtightness? A. Using duct mastic applied on all joints and seams. B. Relying on duct tape to seal all connections. C. Mechanical fasteners only without additional sealing. D. Applying spray foam insulation on duct exterior. Answer. Correct answer, A. Explanation. Duct mastic is a thick paint-like sealant designed for HVAC applications, providing durable, flexible, and airtight seals that withstand vibration and thermal expansion. Duct tape is not designed for long-term HVAC sealing and often fails over time. Mechanical fasteners secure ducts but do not prevent air leakage without sealing. Spray foam insulation improves thermal properties but is not a reliable sealant for ducts. Proper sealing with mastic ensures system efficiency and indoor air quality. Question 26. In a modern context of HVAC design for laboratory facilities, Mr. Patel must ensure proper airflow to maintain negative pressure zones. Which design consideration is most crucial for achieving this? A. Supplying more air than is exhausted to maintain positive pressure. B. Designing exhaust airflow to exceed supply airflow in targeted zones. C. Using variable air volume systems with fixed pressure settings. D. Ensuring supply air is 100% fresh outdoor air in all zones. Answer. Correct answer, B. Explanation. To maintain negative pressure in laboratory zones, preventing contaminants from escaping. Exhaust airflow must exceed supply airflow, ensuring air flows into the room rather than out. Supplying more air than exhausted creates positive pressure, which is unsafe in labs. Valve systems can assist, but require careful control to maintain pressure differentials. While fresh outdoor air improves ventilation, it does not alone establish pressure relationships. Accurate airflow balancing is critical for safety. Question 27. Considering the relationship between heat transfer modes, Evans is designing a wall assembly for an energy-efficient building. Which mode of heat transfer should be minimized to reduce overall heat loss through the wall? A. Radiation, by applying reflective barriers. B. Convection, through eliminating air leaks and drafts. C. Conduction, by increasing insulation thickness. D. All of the above equally. Answer. Correct answer. C. Explanation. Conduction is the primary mode of heat transfer through solid materials like walls, so increasing insulation thickness significantly reduces heat loss. Radiation can be minimized with reflective barriers, but is less dominant in opaque walls. Convection losses occur mainly via air infiltration rather than through solid walls and are controlled by air sealing. While all modes contribute, conduction control via insulation, the most effective method to improve wall thermal performance. Question 20. While examining commissioning data for a recently completed HVAC system, Mr. Thomas notices erratic temperature swings in multiple zones. Which control system issue is most likely causing this problem? A. Improperly tuned pit controllers leading to oscillation. B. Oversized HVAC equipment cycling too frequently. C. Faulty temperature sensors with slow response times. D. Lack of manual override capability in thermostats. Answer. Correct answer. A. Explanation. Improper tuning of PID, proportional integral derivative, controllers can cause system instability and oscillations in temperature control, resulting in uncomfortable swings. Oversized equipment affects cycling frequency but generally does not cause oscillations in control signals. Faulty sensors cause incorrect readings, but erratic swings are more typically a control tuning issue. Manual override absence limits control flexibility but does not cause inherent oscillations. Proper control tuning is critical for stable HVAC operation. Question 29. With respect to piping system design, Mr. Ahmed must avoid water hammer effects in a chilled water system. Which design or operational practice best mitigates this phenomenon? A. Installing slow closing valves and proper pipe supports. B. Using high velocity flow to reduce water column movement. C. Increasing pipe diameter to decrease pressure. D. Removing expansion joints to simplify the system. Answer. Correct answer. D. Explanation. Removing expansion joints is incorrect for preventing water hammer. In fact, proper expansion joints are necessary to absorb pressure surges caused by water hammer. The correct mitigation involves installing slow closing valves that prevent rapid pressure changes, along with adequate pipe supports to prevent movement. High velocity flow worsens water hammer. Increasing pipe diameter affects flow but not water hammer. Understanding water hammer fundamentals ensures system safety and longevity. Question 30. Throughout the course of selecting HVAC equipment for a historic building retrofit, HRConquer is balancing equipment efficiency and preservation requirements. Which approach best satisfies both objectives? A. Selecting compact, high-efficiency equipment that fits existing spaces with minimal alterations. B. Installing new equipment without regard for space limitations to maximize efficiency. C. Retaining existing equipment and supplementing with portable units. D. Downsizing equipment to reduce energy consumption regardless of load. Answer. Correct answer. A. Explanation. Selecting compact, high-efficiency equipment that fits within existing architectural constraints preserves historic elements while improving performance. Installing larger new equipment without regard to space may require invasive alterations, harming historic fabric. Retaining old equipment often results in inefficiency and poor comfort. Downsizing equipment risks undersizing and occupant discomfort. Sensitive demand. A balance between efficiency gains and preservation mandates.